Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 25, Stoichiometry, Part 6. Here are our objectives for today's video. Pause here. Okay, so I'm going to use a little example to explain what the limiting reagent is. So let's just say you are making grilled cheese sandwiches. Each grilled cheese sandwich requires 2 pieces of bread, 1 piece of cheese, and there's probably some butter in there too, but we're just going to deal with bread and cheese for right now. If you have 100 pieces of bread and you have 20 pieces of cheese, then the limiting reagent here is cheese. So if I use all of the bread and I had unlimited cheese, I can make 50 sandwiches. But if I use all of the cheese and have unlimited bread, I can only make 20 sandwiches. So what that means is I'm going to run out of cheese first, and that makes cheese limiting, which means that the quantity that I produce is only based on the limiting reagent. Whatever one is not the limiting reagent, one or ones, because sometimes you've got more than 2 reactants, those are present in excess. What this means in terms of calculations is that you have to actually do 2 or more calculations and just pick the lowest number from the answer. Let's take a look at what that would look like. Pause here. Right, so this is just some reminders here. You must set up the calculations each time. You can't just assume that because the quantity in the reactant is lower that it will be limiting. While that is sometimes true, it is not always true. And then whatever quantity is lower, so let's say you get 2 answers, one's 100 grams, one's 75 grams, I pick the lower number, that's my theoretical yield, and whatever started that calculation is my limiting reagent. Pause here. Right, so this is the same equation that we worked with last video. I'm going to need to do 2 calculations. One where I start with 52.3 grams of oxygen, and one where I begin with 45.3 grams of C6H6. You cannot assume that just because 45.3 is lower than 52.3 that that's going to be limiting. You must do the calculation every time. So just some things to note here. Your last fraction is always going to be the same. So 18.02 grams of H2O for both of them. The last fraction will always be the same because your final unit has to be the same. Otherwise, you're comparing apples and oranges. 11.8 is the lower number than 31.3. So 11.8 grams of H2O is the theoretical yield. It's the maximum amount that I can make in theory. And the limiting reagent is going to be oxygen gas, O2, just because I'm going to run out of it first. The question didn't ask for it, but I'm just going to add that C6H6, which is benzene, is present in excess, which means I will not run out of it. Pause here. So when you actually do an experiment, we will want to see how close to the theoretical yield that you got. So theoretical yield, whether it's from the sort of calculation we just did or the sort of calculation that was in video 24, the answers to those were just also theoretical yield. The theoretical yield has to come from a calculation. Then you go ahead and you do an experiment and you get what's called the actual yield, or sometimes called the experimental yield, which is the amount that you actually got. And then the percent yield is just used to evaluate success. I'd put times 100% in there, but it's really just times 100, just the ratio of it. So just actual over theoretical. And that number will tell us how successful that we are. Pause here. So let's say you do an experiment, you get your theoretical yield, you have your actual yield, and you get a really low yield. So you probably notice here that I didn't put a specific number for what a low yield is, and that is because it is different for every single reaction. So let's just say for this particular reaction, we were expecting a 60% yield, but we only got a 30% yield. Some causes of that could just be side reactions. We thought one specific reaction was going to happen, but a different one happened. Then we could just have some reaction conditions being off. Like we didn't have enough heat. There was a little bit too much humidity in the room. And then there's human error. When I say human error, that is not the same as a mistake. An error is you are doing everything more or less correctly, but there are just factors that you cannot be perfect with. So for example, you're pouring from one beaker to another beaker, and there's just a tiny bit of reactant that was left in the first beaker that didn't get to react. And so you lose that tiny bit. And if you have, let's say, like a 15-step reaction, that those little bits really do add up. Pause here. So if you get a low yield, it's really not too big of a deal, usually in the context of a high school chemistry lab. In the context of an industrial lab, that'd be a little bit different. But a low yield is not the end of the world. A high yield is also not the end of the world, but it's a lot worse. So if you get a high yield above 100, something above 100%, that means that you made a mistake. So a mistake could be that you added the wrong chemical. A mistake could be that you did not tare your beaker before you took the mass. So you did something wrong, because a percent yield above 100% is implying that you are violating the law of conservation of mass, which just isn't something that happens. The most likely reason for that is contamination, which is usually with water. Just means that you didn't dry your product. And then it would be unclean or impure in another way. So perhaps there were two products that were made from your reaction, and you thought that you had removed one of those products, but turns out that the removal was not as efficient as you thought. That is another reason why you would get a high percent yield. You want to avoid this at all costs. A low yield is definitely better than a high yield. When I say high yield, I meaning above 100%. All right, that is all for today's video. Thank you so much for watching, and have a great night.